Okay, can you hear me? And I think you can also see me, right? Yeah, thank you for the invitation and good morning. It's still very early morning here. I'm based in Germany, outside Munich. And I know JP for quite some time. I was working with him 15, 20 years ago, 15 years ago, uh, when I was working for a couple of years for LG in Europe. So um, it's a pleasure to have this presentation. I have prepared a set of slides that are maybe more slides than we can go through. So I will skip a few, but I believe the slides have been shared with you. You can always look it up in a bit more details. And there's also, I'm not sure I added an email anywhere, but you can always contact me as well. Um, Generally, I'm also very open to have it interactive. If you have any questions, uh, I don't know how we do it, but please shout or raise your hand or JP interrupt me if there is questions in the room and we can discuss this so we can keep it interactive during the presentation. What I'm going to do is I'm going to put a bit of an overview of media delivery, what happened over the last, let's say, 30 years, but I focus obviously on a few technologies and just what's happening recently. So what I have prepared is bit of a historical background. There's some principles, motivation, why we doing what we're doing, foundational technologies. I'm a standards person, so I'm working in our standards group in Qualcomm. And so I'm also going a bit into standards, and I also explain why standards are relevant for generally and specifically also for Qualcomm, and tools around this. So tools are like open source tools, development, and so on. As a bit of what's next, where we see some things coming, and this is just scratching a bit around, and I do a bit of a mobile discussion around this, takeaways, and I'm very open for discussions. As I said, I'm working in standards, so I'm basically have colleagues and friends from other companies around the world. I work with people from Apple, from mobile network operators like SK Telecom. I work with people in the TV industry. I work with colleagues from Samsung, from LG, ETRI, and so on and so on. So all of those are included in one or other of these organizations like DVB, MPEG, 3GP. We have SVTA, which is for streaming technologies, ETSI, CTA Wave, and I'm also in bit in the XR space and so on. One of the organizations we have is a Metaverse Standards Forum where we look into interoperability for the metaverse. Okay, so let's just move forward. What I have done is I checked a bit and said, what, when I was at your age and expecting you're all students like in your 20s, your early 20s, um, and that was only like 30 years ago. And that was basically how I was looking back then. And that's what I'm used to a living room back then. So there was a TV set, there might have been um, a radio and there was maybe newspapers. That's what the way how you got professional media from TV broadcasters, highly professionally produced, or radio or potential news were basically being distributed. And there was a very linear setup of these type of things. So basically linear meaning it was the schedule was exactly determined by the broadcaster. And it was typically free-to-air information coming um, over broadcast systems. It was domestic to the local regional countries, regions, and so on and so on. So that was only like 30 years ago, right? So that's the media I was used to back then, and the only other way on mobility you could receive probably radio reception in the car. What happened then is basically in the 2000s, and I just looked back what happened in 2000, you might remember, I believe there was the World Cup in Korea in the early 2000s. What came up is that we started with digital TV. So you would see the TVs have changed slightly. We had PCs and the internet, and we had a first set of mobile devices like phones and so on and so on. So there was all very separated ecosystems back then. TV distribution was digital was transitioning to digital, It was still like you having these live linear events like the World Cup in Korea was basically distributed, and then you had dedicated distribution networks like terrestrial TV, satellite TV, cable TV. And this is not that it does not exist anymore, but it's something that was developed like 20 years ago, let's say like this. And what was happening is that you had a distribution that was very verticalized. So basically, you had pipes, and so the pipes were basically you got the content, you do an encoding, you put it into typically what was back then the MPEG-2 transport stream, very prominent that's still used. It's packaged this, and then it was put onto specific distribution networks that were digital, but they were not. They were circuit switched. They were not internet based to the most extent. So terrestrial TV broadcasting over DVB-T, T2, I think in Korea, you were using maybe ATSC already in version 1, and cable networks, or what I had here, satellites also started to happen. So very dedicated networks, meaning that a TV had a separate tuner that was then being reached. The world changed, right? And what happened is that we got more and more beyond the TV set devices that were coming up to consume media. And the first things were smartphone, tablets. You got reception in cars. You got reception on laptops, and you get more and more into devices and end devices where you consume media like HMDs that basically also accept content, and there's a demand for this one. So broadcasters were then using the media, and the question was how to distribute. And the center to the distribution of media became the internet. And the internet was one of the core aspects to distribute. The other one is to using very personalized technologies on wireless devices. So both cellular with the advance of 4G and 5G, and with Wi-Fi. This is prominent now, basically being that you can access all of these devices through wireless links, cellular based. A second issue what's happened and happening is that content gets different from this professional produced linear content. So you have more and more user-generated content, social media, and so on and so on. And there's a couple of attributes to content that are listed here. So higher quality, the content is integrated with social feeds and networks. It might get beyond 2D, it might be 3D, volumetric. It gets immersive in a sense that you have better quality. Immersion also talks to, for example, new color spaces and so on. It's personalized to you, right? There's something wrong with my slides. I need to check this maybe if it moves on automatically. It's personalized. It can get interactive. So you're interacting with the content. It's could be more like gaming, like you have short content, you have long content, short form like reels, smaller videos, long forms like movie series. You have live content, sports, news, and so on. Content that is on demand, so that you just access on your personal user generated. We spoke about this, and then we get into the topics of AI supported, right? So there is AI generated content. There is also content that is supported by, for example, subtitles, or it's location dependent. It's globally available. It needs to be secured. So there is DRM, for example, involved, so that you need to pay access against this. It can be consumed, time shifted, and more important is also that you want to have an ability to trust content, that the content was produced by somebody you're trusting, because in the area of domain of AI, this is getting more and more tricky. So as somebody who owns content, like broadcast and content providers, you want to make sure that you can distribute content at highest quality, at a reasonable cost, and highly scalable. So you want to reach as many people as possible. So these all creates opportunities and challenges for those who have content. And it also basically is something that demands new technologies. And we want to look into these foundational technologies that allow these type of ecosystems. And what is mentioned here is cellular to the media delivery is the internet and cellular. So this is an approach that has been taken, and I have been promoting very much throughout the industry, is basically that media providers and broadcasters focus on services and basically rely on global media technologies and also on access technologies that are not specific to the services. So what you see is, instead of what we had before, this word, remember these pipes, we now rely that we have a common access that is basically the internet, and you have a 5G, in the future 6G, and I get there at the end, and Wi-Fi as an access. And then we have a set of technologies that are used for distributing the content. You need formats, you need codecs for video compression, for audio compression. You need presentation abilities. Okay, good. So let me continue here. Apologies. So what we're relying on is that basically we have a separation of the access and the transport, the distribution technologies, as well as the service. And you can put many services on top of this distribution. And we focus to having a TV or a content app service. There's also technologies in the production, which I'm not going to speak about, but they're going into similar directions. So basically, that the production of services, so the way how you produce your media is also independent of the access. So very concrete. So you upload your media content in your social app to a platform, and the platform basically then distributes this. And that's what also professional content creators more and more do. They rely on generic uploads and do this as well. These are example standards that are mentioned here that work in this domain, and I'm not going to go into this now, but they come up later. First, I quickly want to check about what are the foundations on the internet and 5G and 6G to give a bit of an idea in which direction we are going. So I'm working with colleagues from Akamai. So now what is Akamai? Akamai is a not very popularly known company, but it's very relevant. It's a company that distributes and offers CDNs and distributes content over the internet. So they offer CDNs, and what CDNs are, they basically offer the ability that you put content on an origin server, on an HTTP origin server, and you can then distribute that content in a highly scalable fashion. So what you have is the ability that content is moving into caches, and these caches are then accessible by clients. And so what you distribute across the world is these edge service caches to store and deliver just data objects. And that all started initially with images, script HTML files, and only at some point videos were added. And I get there how the videos were ended. And that brings the content closer to the end user. So if you request content once, this client, you might get it, and it's not on your cache. So you go back to the origin. But if the other client requests the content, it's stored on the cache, so it's then served from the cache. So that basically pushes the content towards the edge, and by reducing the physical distance between the request and the data, CDN minimizes the latency. And minimizing the latency then increases also the throughput, because that's how, for example, you operate when you operate a TCP protocol. So just showing how this content has been growing. So there's this exponential growth over years. From 2010 to 2016, we went up from something like 1 terabit per second to 41 terabit per second aggregate traffic on the Akamai network. So then if you move forward, this same curve has basically been exponentially being increasing until 2019. So it was basically going up here to 121. And then over the last years, and also with COVID, you would figure out that the content has further grown. So we are at this 250 in 2022 and a half later, also something coming up here. What you would see, one of the increases of the traffic of the internet was really also resulting from COVID, more and more people consuming content during this period. So that caused this. And you also see more and more of these spikes happening. That is when you have high demand events like World Cups and so on and so on. So this is kind of what you see over the network. So traffic grows, but it's not video per se. Most of the traffic we know is coming from typically game distribution. So the largest games that are listed here, Call of Duty, and you might know more of those. I'm not into gaming, but these are really large data. And they are concurrently downloaded. For example, if you in contrast do a football game at HVC, it's 11 gigabytes. So a game is like 20, 30 times larger for being distributed. However, the CDNs are general purpose. And as they are general purpose, you can use them for any type of distribution. The general purpose allows that you can scale them up. So you can use it at some time of the day, of the year for distribution of data, of content, whereas at other times you use it for video. That makes it, from a commodity point of view, much cheaper. And they are basically the backbone to all of our media distribution nowadays, or content distribution. And media is one of the core topics, but it's not the only one. I said there is other traffic as well. And you have these peaks to sports events. And for example, Super Bowl 2023 needed more than 60 terabits per second. And this growth have happened over the last years. So there's also, you see this is the latest one. You see a bit of the exponential growth has stopped a bit. So we're here in 2025. I just got this from my colleague yesterday. So it's still growing. There's reasons for this, which we can go into why it's not exponential anymore. This is also with the business model of Akamai. And that, for example, the large service providers more and more deploy their own CDNs, like Netflix or Amazon have their own CDNs, and I expect the same is happening in China and Asia. But how does the OTT, the over-the-top, keep growing, and how do we address basically the issues here? And so this is just from a high level to understand. For access there's two tracks to work with the demand of more and more traffic. So one is, do you do brute force and just increase the capacity of your networks? And I have here pointers for Ethernet, cellular, fiber, and Wi-Fi. I'm not going into this, but the access bandwidth for these technologies is continuously growing as well. They basically double the available bit rates by a factor of 2 every 2 to 5 years, depending on the technology. So for cellular, we're going into 5G, 6G. For Ethernet, we're going into new technologies. Fiber is still improving, and Wi-Fi as well. The second one is to use smart technologies, right? So basically, there's technologies that allow you to scale up the content demand need. One is working on the distribution. For example, you can integrate a certain amount of smart peer-to-peer, meaning devices talk directly to each other. So you're not going to the network. You can serve across devices. Multicast and broadcast are considered technologies to scale up. And the other one is to basically operate with more efficient codecs, right? So this is over every 10 years, we get a gain in a video codec of like 50% expected, and that also allows to add more services or better quality into this distribution. Okay. So now I want to go more into foundational technologies, how to deliver video over the internet. So, and this is kind of the core of the discussion now, and I want to dive into these technologies. Remember, this is the distribution. So where we're going to go now is into this distribution technologies, formats, codecs, presentation, and CDPs. CDPs stand for Content Delivery Protocol. So I'm going to focus on this one mostly. There's a bit of discussion about APIs and codecs and formats, but the focus is really on the content delivery protocols. So this is how content is distributed, and that is a busy slide. But remember, we have like an origin server that produces content. And what we're going to do, that each media is produced in two ways. It's basically produced that you generate media, your content in different bit rates. So you have in different qualities. So you get your video at the anchor being produced at, let's say, a 1 megabit per second, at a 2 megabit per second. version, and so on and so on. So you have different bit rates, right? So this is indicated in that direction. And you create a smaller files that have a duration for, let's say, 2 seconds. So now you have a video content of like an hour is split into 30 times 60, 1,800 files per quality. And then you have several of those are also for different qualities are available. So this is how you generate the content. And then you push this onto CDNs. So on CDNs, this video content is just a collection of maybe 10,000 files that you can now access as a client. And these files are accessible through HTTP URLs. And clients then request those. So now, how do clients know what they have to request? They get a manifest, and that manifest describes how to relate this content to create a continuous streaming content that you then look into on your screen. So the client basically makes all of the decision which what is called segments. So segments are the smaller pieces of content to download, puts them into the playback session, and then goes ahead and splits this. And there's another typical issue to be addressed, that is that this content is all distributed in encrypted. So you have a license. So there's individual licenses, but there is also encrypted content that is common. And so that's what you basically access, how you access the content. And that is the foundation to video and media distribution nowadays. So it's referred to as adaptive HTTP streaming. This is how live and on-demand content is distributed today over the internet. So explaining one more time, so you basically have, in this example, 3 qualities. Maybe they have different resolutions at different bit rates, a high, a low, and so on and so on. And maybe a user is even transitioning across different networks. And when transitioning, you will observe different bit rates. So HTTP is it's basically stateless and can work on different connections seamlessly. So, and then depending on your access bandwidth, you will choose different qualities. And that's what you observe. If you watch content, you might once in a while see some reduced quality, but the idea is always to have a continuous service, regardless whether you have the bitrate that the access bitrate is low or high. Obviously, the goal should be to operate on a constant bitrate and quality. So that is the objective. But what was observed is it's much more important that you have a continuity of the content and no buffering instead of basically buffering. And that's why this adaptive streaming is so relevant to be addressed. Okay, so now these technologies were founded in by Apple and Microsoft proprietarily, and Adobe and a couple of others in like the late 2000s, so 2008 and so on. That's where adaptive streaming started. And what happened then is that there was a request from different market players, as well as from different standards organization, MPEG, 3GP, the Open IPTV forum existed back then, to create a common global standard. And that was resulting in the first global standard that is referred to as MPEG-Dash, and that was then finalized in 2012. And it led to some additional work in W3C, and I get there in a second. And there was a foundation of a group which is referred to Dash Industry Forum, as I was working in this group for 10 years, and or now 15 years, I'm still working on this. And we basically support the industry to deliver solutions that is here. So the standardized format basically allows that you have confidence for distribution and implementers, like TV sets now implement Dash. That's how you can get content onto the media. So you have a Wi-Fi access point and a Dash client, and that's how you get content onto this TV. This is just a list of the standards. So there was a first standard being available. That was in 2011. It was actually published in 2012. And then there were many updates being done over the years. And you see, I was involved in, I was like the main editor for this for quite some time. So this standard developed. And there's also other parts that supported the implementations and looked into other topics. So I'm not going to go to this. I'm just saying the standard itself is a long development. And what it's also, it's by now like a 400, 500 page document published by ISO that addresses many different use cases. So there are some core principles to this technology that speaks to what I was saying before. And the Dash Industry Forum, which I'm not going to talk more about, there was an organization existing for 12 years, 13 years, now is part of the Streaming Video Technology Alliance. Many companies were in there. You find also probably familiar companies from Korea, like LG is here and Samsung is here. I believe Etsy was here for some time, and so on and so on. These are 9 foundational principles that were used. So the first one is the technology needed to be CDN and cache friendly. So what I explained before, so making sure they can operate on top of CDNs. You have a stateless server. So the server is not aware of basically the state of the user and individual users. So all of this, the state of the session is created in the client. The client creates the session. The server is stateless. So that makes the distribution much more cost efficient. It needs to work with DRM and encryption. So that was one of the core foundations, because many of the content is high quality, professional, being produced by studios or being accessed only behind like paywalls or subscriptions and so on. So it needs to work here. The manifest that I showed that describes this 10,000 files needs to be small in size and small in update, because if the manifest file is large, then the access to the content is slow. It's very inflexible. So that's what we want to keep small. We want to work with carrying a format that I get there in a second, the ISO BMFF. You want to do something that is called late binding. It should work with the browsers, and I get there in a second. There's a convergence with the technology from Apple, HLS, I get there as well, and it should work for live and on demand at the same time. So working with HTML5 and MSC was one of the requirements, basically, that also significantly scaled up the availability of media, because that is the ability that you can consume content in your browser. Your browser, your Chrome browser, your Edge browser, and I don't know what people use nowadays, Firefox, you consume content in the browser. So that abstracts and gives you the ability to have also a framework to present, interact, and so on and so on. And there's a technology that is referred to as HTML5, so that is the presentation language, and then there's an underlying foundational MSC technology. I get there in a second. So I'm going to focus now on those topics and jump a bit in the ISO file format. And that's where JP said, you had a presentation a couple of years ago that was interesting. There's the presentation here. You can go there and look at this on YouTube. And the ISO file format is a container format that allows you to package content. Many people view the file format as just a list of boxes, right? But it's not just a collection of boxes. It has principal aspects. So this presentation is longer. You can go here in the details. The slides are here. I'm going to jump to, in the interest of time, over a couple of principal topics. So what is the ISO file format? It contains structural and media data information, principally for time presentation of media, such as audio and video. And you can also add untimed data, like images, metadata. And you can structure the file in different ways, but it's the same core specification that can be used for files for capturing content. So, for example, if you record content on your mobile phone, you put it into an ISO-based media file format, or MP4 file format, so which is basically the base just stands that you're using common technologies, and then you extend it to like your core format. You can exchange content. If you send an image file to your friend over WhatsApp, or I don't know what you're using, WeChat, then you using and package this into an ISO-based file format. You can do local playback if you put this. You can do also, it's easy for editing, composition, and layout, and it's now basically also used in the streaming content. So by reusing these files, this commonality, you have a lot of workflows available that you can use for many different purposes. And that makes it so interesting and flexible. And it's also a lazy way to basically reuse what exists. So laziness is one of the core issues that you need to learn in engineering. So reuse what exists, right? So don't develop everything yourself. If you reuse what exists, you can scale it up and benefit from this. Historically, that was developed much earlier than the streaming. The first specification was published in 21, also out of AMPEC. And so this is a bit of a history. There was now several specs released, and we are at the 8th edition right now that is under development. So this is just historic. I'm not going to go through this, but it's continuously being improved. These are some features that have been added. And it's integrated into a suite of technologies. Again, that might overwhelm for a student's webinar, but it's just showing that this is the core of the ISO-based media file format. There are extensions into this for video, there are extensions for this for audio, and then it's basically used also for images. And then you use it, as said, in the distribution and application formats. And there's more application formats now. So what you see is many of those refer to the ISO-based media file format or derivations. So meaning that's the center of all of these technologies. There's also an encryption being built that is harmonized with here, and that allows you to distribute encrypted content that you can then only access if you have the specific license for this one. In principle, what these files have, they have logically a structure. They carry a movie, and this movie includes different tracks. So the movie has an audio and a video track, and it might have an audio track for the language of English and the language of German. It might also have a subtitle track for Korean subtitles. It has timing structure. So each of the tracks contains samples. So a video frame, an audio sample, and those are sequenced. And it has a physical structure, which is a series of boxes. And these boxes are constructed in a common manner that you can do easy editing and random access and so on. And they're not necessarily coupled. So I skip these details now. I have a couple of figures. So that's, for example, how you store a movie, right? You have some movie information. You might have some static information, which is an item. And then you have a video track and an audio track. And they are timely synchronized. And each of these tracks contains of video and audio samples that are compressed, for example, with a video codec like AVC or HEVC and so on and so on. There's physically the organization in what is called boxes. And boxes are this foundational way that you can put in a character, a 4-digit printable character that explains what the box is, right? So there's, for example, I'm describing the movie, or I'm carrying metadata, or I'm carrying media data or image data. So that's what you can, and then the boxes are more detailed. They all have a size included. So if you don't understand the box, you can typically skip the box and so on. So that makes it extensible. So very smartly designed. You can go into the details. This is, for example, the ability how this is built up. So you have a series of high-level boxes, and then they're breaking down into smaller boxes. So we have a movie. A movie is broken down in a header and a track. And then you have a track header, and then you include media in this. And then you go down into something like sample tables and so on and so on. So this explains it a bit. So it's this hierarchical structure that you can then implement into different physical concepts. So this is another explanation to this one. So you have a track, and the track basically in a movie, and the track then is not you have indices that refer to samples, and so you have an index that is a combination of a time and a physical location. It points to a container that contains all the media. So you have this metadata up front. So what does it allow for? It allows for that if you download this movie header, right? That might be a smaller piece of data. Let's say it's a megabyte of data, and that contains all of the information where you find the samples for a specific timing. So what it allows is that you can now randomly access and say, I want to go at the video time at 30 minutes. So you don't download the whole MDOT, but you only download the samples that are relevant for when you want to play back, or you put this into your player. So it gives you this flexibility that you separate the timing from the physical access. You don't have to parse from the beginning. That is, for example, a difference to the MPEG-2 transport stream, which is built in a linear fashion. So that was built for linear TV. So I skipped those. There is times included there, that the times are used to give you two information. So decoding and presentation. So decoding is, when do you have to give the sample that is associated to the time to your decoder in order for the decoder to be able to decode it. And the second one is when the sample that I'm giving to you is presented. They are typically related, but they're not always the same because there is some structures in media that doesn't allow this. The presentation then is mapped to a common timeline, and that common timeline is then used for synchronizing different media, audio and video, and so on and so on. There's metadata included. I skipped that. There's also the ability now to fragment the files into smaller chunks, and that's where basically relevant pieces come. And that was developed in the ISO file format a long time ago. It was developed for the purpose of recording, right? Because when you record, you want to record smaller amount of data. So that's called movie fragments. And these movie fragments split the content of tracks into smaller pieces of like 2, 5, 10 seconds. You can decide this. And each of those gets an individual header assigned. And so you have a series of fragments in the movie. And you can at the end say, I created a movie fragment random access, which points them into the file where you find this individual. All of this is, again, based on boxes and offsets, on sizes, and so on and so on. As a extensibility concept, there is an extension to video, so where you basically can put in all the video-related information into this file. And there's also derivations for other media, which I skip here for the interest of time, but you can digest this if you're interested, or reach out to me. There is an ability to extend it for encryption. There is a specification referred to as common encryption, and that extends new boxes. And these boxes include information that a decryption system needs to use in order to be able to decrypt this. And that includes both. It includes license information, so protection-specific headers. That includes how you contact your license server. And it includes information about the encryption mode. And there's different encryption modes, for example, a block cipher or a counter mode. And there is these are all security concepts as well, if you understand security. So that's what you find as well. The good thing is, technology is not just a specification. There is a lot of tooling built around of this. And you can go to a website that is referred to as MP4RA, where you can register. And there is software being provided for this. And this software is very broadly available. Packages, and because there is a common base software, this technology got so popular because so many people can make use of this. So again, these are pointers. You can look this up. There's open source and commercial services available, MP4Fox, FFmpeg, JavaScript implementations, and so on and so on. Now, there's a foundational concept that you can play back MP4 files in browsers. Okay, so this playback in browsers is actually very interesting because it allows you that you can put content and refer to this in your HTML media page, and then you play content on your browser. So, but there is a functionality that is called media source extension. And that was one of, in my opinion, one of the most important innovations because this media source extension allows you to feed smaller pieces of content into your browser pipeline while downloading this. And that enables that you have support of streaming in there. There's a relatively simple JavaScript code that you can use to then access content. So you initialize this one, and then you append. So you basically download through your get and append this to the buffer. And that is about the script that you write to run video in your browser. And there is a lot of sample code, and you can start engineering around this one. You can do all of this yourself, and I have a bit more pointers later. But that is the flexibility and the beauty of this technologies we have built, because it makes it simple and flexible to be played back in browsers. And browsers are also the foundation of TV sets nowadays, for example. So if you're interested a bit more getting the technical details, go to MSc. There is formats here, and there's also reference implementation. I get there in a second. So now this technology ISO-BMFF is used in streaming. And why are we using a file format in streaming? Because what I told you before, the streams are object-oriented, right? So we basically distribute content as smaller pieces, and then we leverage a significant amount of the functionalities, media encapsulation. All of this is already built. So all of the workflows are available, and that's what is written here as well. And now we map this back into this media presentation model, and that's basically how you now use the ISO file format with all of these box types, and you put it into objects that you deliver over media. And the objects are basically now you have an initialization segment that tells you what the content is about, and then you continuously download what is called media segments, and they include a series of fragments, and these fragments are then these 2 or 4 seconds movie snippets, and they get into one representation. And that's how you build up your content media here. So in Dash, what we specify is 2 things. We specify now a manifest, which gives you the pointers to all of these smaller pieces of segments. And this manifest includes the HTTP URLs where you find this. And the resources are also specified because they are specified using the ISO-based media file. And what the client does now, the client just accesses this content, downloads it, and puts these downloaded media into media engines. Now, the client itself can be instructed by an application, by a user interface. For example, I want that you start the media not at 0, but start it at 30 minutes. So this access client will use the manifest to translate this, what resources to access. Or it might also translate the request of, I want this language. So it will only download the media that is contained in this language. So all of this is basically then under control of a client implementation that accesses the content on the server. And the server does not even understand that it stores, that the files it stores is media. It actually just stores files. So that is the commoditization of the distribution over CDNs. So this is shown here a bit more. You can basically now switch across different representation qualities for video, for audio. You might have English and French, so all of this, and you can also split it into periods. So these are different content. So this might be your main content, you might have an ad insertion, and so on and so on. So there's a lot of flexibility now being built up. There's also a concept that is referred to as late binding. And late binding allows you that you avoid a combinatorial complexity of aggregating files at the server. So you might say, I want to have the HD version together with the English audio. So you can download now all of the HD version, and you can download the English language. Whereas somebody else might pick the French language. So then you can combine this flexibly. This avoids that you have to multiplex this content. This is all individually available, and the combination of the data in the playback is done by the client. This is what's referred to as late binding. Another very core and principal concept that is relevant and differentiates, for example, what was done for the MPEG to transport stream for broadcast distribution. In order to make this happen, you have, if you would have a video, you describe all of this in the move box. So if you don't have the move box for each track, you need to put this information to the manifest. And that's what you find in a manifest. So this is a dash manifest. It's an XML data. And that XML data is just describing this concept of different aspects. So it describes two dimensions, a time dimension and a choice dimension. And so you would find here a time dimension over time. This is described here, that you get a media over time, and you can have choices. And the choices is, for example, you have a video content type, and you have, I think there's also an audio content type here somewhere. So these are the choices you get. So it's just XML data that the client accesses, and with this information, it can then operate and move forward. There's a manifest for live. And again, I'm not going to go into the details. I'll leave this for your offline consumption. The problem with live is that you can describe the content only to a certain amount of times, and then you need to regularly update the manifest, because you need to get the information when and where this new data is available. And that live operation causes some issues because you need to download it. So then the manifest every 2 seconds, for example, you need to reprocess this, and so on and so on. So there is a couple of aspects that need to be taken care of. What you do here, for example, for live, you put in a list of segments here. So you produce 0, 1, 4, 2, 3, 4. This is a list. There's something smarter that you basically say, I don't give you a list, I give you just a template. And the client then uses this template and adds the number for itself. So you get an HTTP URL and say segment, and then you basically add the number. And the instructions, and that include both. It includes the URL where you find this segment, and it also includes a time when you can get access to the segment. So this is all explicitly or implicitly included into the media. So because you have durations, and these durations then allow you to basically to fetch this. This is an idea of the playback. So you get a manifest that is produced on the server and describes the content, and then you fetch this content. The content describes all of the media segments up to 2. Then you know that 1 and 2 segments are available. 3 and 4 will be available in the future. And then you basically get a suggested playback delay. And that playback delay is then executed by the client. So the client basically downloads the content, puts it into the buffer, and with some delay that is kind of suggested by the presentation, you start playing back the content. And now over time, this content gets available, it gets announced in the MPD, and you're moving forward, playing back this content, downloading, and so on and so on. So there's this sequence which you can execute here. I skip these aspects for details. There are more variations of manifests, so I'm not going to go into this. There's also abilities to optimize for on-demand, where you use indices, binary representations. These are all optimizations that rely on the same principle, but just optimize for specific context. So I skip this as well. And I said there is multi-track models, so the ability that you can offer rich content there. So multiple alternatives. So there is, for example, also the idea that you can offer content and from different viewing angles. You can use different codecs. So there's a lot of flexibility being added that you can input into your manifest. Give me 1 second. Yeah. Okay, so all of this was actually built under the umbrella of dynamic adaptive streaming, and actually that was recognized by the industry. It's heavily deployed, and in 2022 we were awarded with an Emmy, and we received this in Las Vegas. You would find here the inscript into the statue. That is me, but you also would find a colleague here, Kyung Mo. You should know him, JP. Many people in Korea might also know Yang Kwon Lim. He's a colleague leading the working group in MPEG for a long time. These are colleagues from, for example, Netflix, and then there is colleagues from Microsoft, and so on and so on. So just to recognize this one is here. So that was in 2022. Okay, so there was another development that is on top of Dash. It's called CMAF, and I get there. It's a commercially driven evolution of ABR streaming. So CMAF stands for Common Media Application Format. And I'm going to explain very briefly. So we have seen the development from this linear TV distribution to using this adaptive streaming. That was introduced, and it was, so what you see here now, it's just a recap what I showed you over the last 60 slides. So this is how this adaptive streaming worked up to 2016. So we had Dash, which was a foundation of a standard, but there was still a continuation of some proprietary format. So there was a format from Apple under the HLS umbrella, and so on and so on. And I need to stick back here. I don't know why we have this automated distribution. Okay, so the problem was that you have different formats of content. And so what was then done is that that increases costs for distribution, because for each of the streaming format, you had to have CDNs being built up, and so on and so on. So while Dash was a standard, it was not completely embraced by others. So what was done then is that we took another step and harmonized further. So the idea was now to have a format that is CMAF, that is common to all streaming formats. And CMAF is, again, fully built on the ISO-based native Frankfurt. And at the end, this resulted in what is now referred to as CMAF. And that's a common format across people. That includes also now people from Apple. So those two folks are from Apple, and Netflix, and so on. So we did another step to basically harmonize further beyond what was done in Dash. So we have now two streaming ecosystem, HLS and Dash, but they use a common media application format. So that's what CMAF is about. And so what we did is we mapped CMAF onto Dash to basically have this, and that was straightforward because many of the concepts are exactly the same. Okay, so I leave it at this, and that is for CMAF. I want to go and explain that all of this is supported by implementations and tools. And as said, we wanted to look into playback on the browser. And that was the first core implementations done, because this is where there was the most demand. So if you would have been around in the 2000s, there was something that was referred to as plugins in browsers, very cumbersome to basically operate and playback video in browsers. There's still the ability to put a source element into the video that you would rely on a native playback. But that native playback is something that is once in a while done in like more closed ecosystem. I know Samsung AV Play, for example, does this HPV. In Safari, that was done. There's a type 2, which I'm not going to go, but there is this type 3, and that is what is referred to as using the media source extension and the encrypted media extension of the HTML. So, and that's where all of the modern web players like Shaka from Google, Dash.js, the reference players, are built upon. And this development gives you flexibility and gives you a lot of opportunity to develop and improve and so on and so on. These both are open source projects. You can look into this. And there is here this media source extension you can go to and accept. And there's also something for encrypted media playback. This is an overview of the browser-based streaming technology. And there's different layers. There's the web API, and then there's a JavaScript object, and then there's a lot of underlying functionalities. But on the surface, this is what is relevant. So on a browser, you get exposed to these APIs. So you basically map the content to an HTML video element, and that video element gives you like a canvas where you can play the video. So you see it on your web page, and you can put it into full screen, or you can put it side by side, and so on and so on. And the element basically references is combined with can create a resource which tells you I have a media source and a source buffer where you can add media, and you can also connect it with EME. And the combination of those three allows you to have this flexible playback on the browser. And we use this functionality to create a reference tool implementation of the Dash standard, and that was the reference player. So this is here, and we also support this with many other assets like example offerings for content and so on. So this was a foundation of the Dash F to build all of these interoperable ecosystem for independent implementations. So let me jump into Dash.js. And I encourage students to look into this. This is very interesting. You can download it, you can play with it. There's a lot of functionalities here. So Dash.js is the official reference player by the Dash Industry Forum SVTA for playback of Dash content. We have a maintainers for there. There's a latest release that was just published like 2 weeks ago. It's very often being used. It's written in JavaScript. It works on many browsers, desktop browsers, smartphones, smart TVs, but the nice thing is you can do this in your browser directly on your PC, laptop, and so on. There's many functionalities supported. You can read those, and I have a little bit later. And it has a web interface, and you can also participate. It's an open source project. You can go there. There's a GitHub page. There's a reference client. Which publishes samples. And so this is the interface, okay? These are a couple of numbers. There's 60 releases, there is 1,700 forks, close to 200 contributors. There's many downloads, and there's a developer community here as well. How is it used? It's used as a reference project for us in the standards, but it's also used by industry. So the industry uses this player for distributing commercial content, BBC, Deutsche Telekom, Arte, and so on. And it also is used to compare the behavior of commercial players as well. And then it's also used a lot in research. So again, encourage the people can look into this, and they use it for like ABR algorithms, for for testing new ideas and so on and so on. There's a lot of openness here, but you can always build on something that is used by the industry. There's this nightly samples here, which you can go to, and I have a couple of, no, I don't have examples here, but let me go here for a second. I think that's the first one. Okay, I push it over here very quickly. So this is Dash.js, and so you can go here, and for example, there's different aspects. You have an ABR logic, and okay, we go there. So you have a player here. It plays a video content. You can put it into full screen. It gives you some ideas here. This is the source code for this one. That's what you can look into, right? So this is an idea. You can also go back. Let me go to another one. There's an example for what would it be? Checking advanced. For example, subtitle and captioning. You can show, for example, multi-track captions. That was too brief. That didn't work. Get to this one. Yeah. So you can now get, okay, yeah, you see now you can test captions and so on and so on. There's also a code here, all of this. So all of this is very instructive, and again, open source, you can play with this. There's a low latency life. I believe this is interesting. Test player. Yes. Load stream. Okay, so you also see, for example, you see some graphs here. So it shows you the delay of the content. So for example, what we're seeing here, we get an end-to-end latency of less than 3 seconds. You see the buffer level, so how many of the data is in the buffer. You see the playback rate and so on and so on. And now you can play on some settings, and the settings are optimized by the application then. But you can change these settings, and you can understand what's happening if I change settings. You can also program. There is also the sample code here. So again, all of this is very accessible and can be used for many different purposes. Okay, let me just go back here to the presentation. There's some reasons updates, which I'm gonna be. Yeah, so there's low latency streaming. I showed this in a second. So this is used for sports streaming, for betting, for esports. So here you really want to reduce the latency from the event to being seen at the user to something like 1 to 3 seconds, 5 seconds. So there was quite some work being established here. And the Dash concepts are heavily building on the ISO format and on something that is called chunking. And what you do here is that you use a technology that is referred to as HTTP 1.1 chunk transfer. So this allows you to start distributing a resource before it has been fully produced. It's very smartly integrated, but it gives you all of the benefits, and it leverages CMAF to get to latencies that are now comparable with what you get over terrestrial distribution. That was a huge step that mainstream service providers are using now Dash also for live as the mainstream distribution. It's not only built for on demand or for kind of just as a complementary it's used now as the main distribution mean for live services for media. So I showed you the live demo already here. There's another one that is referred to as common client data that allows you to collect on your client, but also in an aggregated fashion throughout this service, a lot of client data. So you're observing, and you can use this for forensics, for log analysis, for quality of service monitoring, and so on and so on. So that's a parameter collection. You can also try it out here. I believe, let me check one more time if this works. Keep verification. Yes, this one is here. Yes. So now we are playing back here. And you would see you're collecting metrics all the time. So it gives you, for example, what bitrate am I consuming? It gives you what is my buffer level, and so on and so on. And so that's collected here. And that information is then sent back to the server, and the server aggregates this information and makes use of this. Okay. So I move on. There is new extensions in the 5th edition. I'm not going to go into this. And we did a significant update in the 6th edition right now. Very interesting technologies, a lot of advanced updates, in particular for ad insertion, which is getting more and more important for commercial services. So you can read on this in a bit more here. So now I want to spend at least maybe 10 minutes on mobile and 3GPP, but we have not enough time. I gave you all the foundations. So now Qualcomm, the industry is very interested in making sure that you can operate media on mobile devices. And we also have an implementation that we have global devices, Apple phones, Samsung phones, they build globally. So we want global standards. So what we're addressing in 3GPP is to create profiles and interoperability across different aspects. So there is an interop for codecs, content delivery protocols, access and distribution, security, content protection, provenance, rendering and presentation, quality of service and quality experience, and data collection and intelligence. The latter one getting more and more important in the area of AI. So we're building foundational technologies in this area, but not always inventing, but just profiling and using what the industry and standards organization have been developed. There's video topics. I skipped this for the interest of time. There's format interoperability, for example. We're looking into how you can distribute, for example, stereoscopic content in an interoperable manner. And there is media streaming. And media streaming built in 5G is very heavily relying on many of the concepts you have seen now. And I just want to give you a quick animation for this one, which comes here. So the idea is that we use an existing media player, a dash player, and a server, but allow that there's a certain amount of control being given in the mobile system to basically ensure a quality of service and a consistency. And what you do is you just put a session around your media delivery in the mobile network that allows you to control certain aspects. And I have an animation here that should start here. So you can get an access to a service, and that access to a service will then set up a session for you. That's shown here. And then you ask, for example, playback the content, you get an MPD. So that's just another indirection. So you have build a session now along with this, and you get now a response here that you see that includes a URL to an MPD, so a dash manifest. That is accessed. And then now you get a response. This is your MPD from a 5G media streaming server, and then you're requesting all of the segments. And I believe that is timely because This is our colleague from the BBC sending some Christmas greetings around the world. So the main idea is that we reuse the existing technologies, we create a session around this. And once you have created that session, you can leverage all of the 5G or mobile network benefits. So, for example, you can ask the network to support. If your buffer is draining, you can ask the network, give me some specific treatment for my data. You can change your QoS settings dynamically. You can send data about reporting like CMCD or metrics back to the network that it can use for operational purposes. So all of these features are now integrated into the environment by putting this envelope, and that is for the benefit of mobile network operators to optimize the services. There is also work that I spoke before to address scalability. There is the idea to create multicast broadcasts. So basically, over the air, distributing the same content to many different services. And there's two modes. There's a 5G broadcast mode that is more built towards tower casting, and then there's one for mixed. And I skip all of that now for the details. You can look this up. There's a lot of new work we just completed in release 19, work about advanced media delivery that is shown here. And there's many technologies defined that are interesting and speak to the industry. I just want to give you an idea that this is a very living community. A lot of new activities happen over time. It's very active, and it's also an invitation for students to go into this professional career. You can read of this. All of the 3GP technology discussions are public. There's a technical report available that documents all of this. There is a technical report for broadcasting, multicasting available. This is here. I think this just repeats it. I don't know why. These are topics that have been looked at. You can look into this. And I skipped that here. And we also have defined something for the next release where we look into new topics as well. So just to give you a bit of a liveliness here. All of this is linked. I would have a full presentation about 5G broadcast, which I skip here, but as I'm personally very involved, I encourage you to look into this. So that is basically a combination of a broadcast technology, all of the advances we have seen here, but also speaking to tower companies that want to directly reach with their towers, like your tower in Seoul, from this tower directly going to mobile devices. So that's the idea here. And so these are the features that have been defined. And it's a 5G technology for media distribution that allows the broadcaster, the classical broadcasters, not only distributing to terrestrial stationary antennas, but going directly to mobile devices. And so there was a lot of smartness into this being put, like that 5G broadcast reuses most of the technology you already have. And we have already prototypes on this available and so on. So there's standards here, and I skip all of that. Standards, communities, integration. We're using the same foundational technologies. We're using Dash for this as well, despite it comes over broadcast. It allows you to combine this with unicast. We support all of the features. We talked about a few of those. The SHLS, CMCD reporting, ad insertion, lower latency. All of this is combined now with the broadcast functionality. There are standards organization on this one. And this just shows we're pretty far. We completed most of this, and we are now looking to launching this globally. There's an adoption path. There's some interoperability discussions, multiplayer models. I skipped that. There is a lot of work happening throughout the world. We have Malaysia, India, China. They're all looking into this and deploying this technology globally. You have test platforms available. And what I wanted to point to you as well, and that's important for me, you can look into this. I go here. too far. All of what you found here, what I talked about, is open to public. We have reference tools developed in 5G Mac, which you can access, and you can start playing with this type of things. And it's built for students, for lab projects, for going into this. And you can get a reference implementation for 5G broadcast. You can get a reference implementation for 5G media streaming. You can start playing with this. You just go here, 5G Mac, getting started. So I distributed the slides. There's mailing lists. We have colleagues that join our public calls. It's every Friday. It's a bit late for Asia, I know, but if you're interested in this, just join the community. There's a lot of opportunities to create projects in research, for working with your content companies in this area. What I wanted to give you at the end, a very quick outlook into 6G. And we are developing 6G right now. And developing means we're starting just with foundational aspects. And what I wanted to just show is that we have a change in user behavior that we are expecting for reasons that we believe the media consumption will change. And there's aspects that includes new devices, and also includes AI. In Qualcomm, we now have a set of devices that we power. So it's not only the mobile device, which is still very relevant, but we also have compute platforms. We have glasses, wearables, and more going into other topics. And these are basically where we have a connectivity, compute and AI is combined into these type of things. What we expect is that today we have app-based interaction. The user interacts with app, and that will change, that we get a behavior that the interfaces, how you will communicate, will change over the next 5 to 10 years. So we have much more natural user interfaces that use gestures, voice, and also AI agents basically taking over duties. For example, you have a communication. That is already happening today with all the glasses that are developed, that you have more natural user interfaces. What's happening for this is that this is coming through the race of AI agents, the new form factors, and also new usage pattern. What we also expect is that we will see much more traffic in the uplink, so content being produced on devices being sent into the networks. And that could be done by agents, by AI automatically, by continuous sensing and monitoring, or it could be done by users itself, right? So all of these patterns we expect to happen. And we also require then this inferencing is going to be distributed. So that is also meaning that we need central cloud access, but we also need potentially smaller latencies at network edges. And what we consider is that 6G is going to be the technology that will heavily support these AI-driven applications. Okay, and 6G, as said, is the idea to connect this on-device AI on these many different types of devices with a central cloud and the edge server to support these different applications. Agentic AI is one of this, and that is then going into what we refer as, one is collaborative communication. So the idea is that your devices will connect among each other, and they will connect with all of their data collected being to a cloud server that can process the information that you're having from your local devices. So your glass, your phone, your wearables. And that allows you to basically then offload things like rendering, perception, or AI, generative AI, into the cloud. But make all of these functionalities very connected, right? So So perception, for example, you understand your environment, you know where you are, you can basically ask a question, what is this building there? So this perception is handled through AI on the edge, but you can connect. But you need to send data, either the full scene by recording it, or you need to do a certain amount of scene understanding on the device. So this distributed compute will be a huge topic moving forward. And then another one is context awareness. We believe more and more there will be an understanding of in what context you're operating. Are you attentive? Are you away? What is the application you're running? And that information will be used in the communication to optimize this as well. So there is examples available here as well. For example, depending on the complexity of the scene, you might allocate different resources. So we expect that the radio is more user experience oriented. And there's some research here that shows that you can do something like this. And to bring this all to life, we have started very concrete project in 3GPP in the 6G area to move topics forward. One is avatar communication, for example. Avatars are getting more popular, and we want to integrate photorealistic avatar into services. There's advanced video and image formats that are to be used. Another topic is the integration of new access networks, satellites getting more and more prominent. There is a quick and new media protocol that is under development, and we're reviewing this. There's the work on the advanced media delivery. Another important topic we'll be observing in the generative AI area is, can I trust the content or the person that I'm talking to? So how can we get authenticity in the communication? Messaging is an important topic, exchange of data. Then we have a new format that is referred to Gaussian splats. So that basically relates to the above, but a new format that is at the intersection of 3D and AI. It allows that you can use regular cameras, capture several images, and produce a 3D content that you can run here. User experience services that talked about AI spatial computing, the media over NTN, that's what I speak, and some consistency on data channels. This is for app operators, okay? So this is started. There will be more work coming, but I'm just saying we're filling the concept that we see before with life. At the end, we see for 6G is really this this combination of the technology with AI, XR, low power, and 6G is being designed to meet the next generation user experience. And we are in the center of this, and this is an invitation as Qualcomm. If you're interested in having internships with us, we have offices in Korea. If you want to interested in our company, work with us, but also work with us from the university on the open source project I was referring to. Okay, good. I leave it at this. Thank you for all of the attention, and I hope I did not overwhelm you, but if you have questions, we can discuss now or anytime later. Thank you.
Thank you. Okay, thank you for your presentation. Actually, I'm Liu at the head of this department, and actually, you might remember me. I met you at the last Geneva meeting in Working Group 3.
Oh, okay, yeah, good.
Yeah,
I remember. Yes.
Yeah, formerly I worked for InterDigital's video standard team, and then later I joined the university. Okay, and today, sorry, I have actually another meeting out of campus, so I couldn't join your presentation fully. Attended the meeting. I have just short question. Actually, this is just basic question about this kind of video streaming issue. When we talk about 5G, 6G, at least we are expecting more than 100 megabps for example, 500 megabps network bandwidth, and we want to deliver, very good video data over the network. But, as you know, in the video coding area, every time we are talking about 5 megabps and at best 10 megabps. So, these two directions are too much different. So actually, even when I developed the volumetric video data, by using the multi-view video coding, I expected more than 100 megabps because we have a lot of 2D videos. And then by using this one, we are, generating the volumetric video data. But, still video coding area, they are talking about 5, 10 megabps. So how do you think about these different two directions, for example, in the future, especially for thinking when you're thinking about the 6G network? Just wonder your opinion.
Yeah, it's a good question. I think it's a continuous discussion, right? So, are we saturated? So don't we need this anymore? I believe the bandwidths we're talking in the 5G, 6G area, they are typically peak bandwidths, and obviously they need to be shared across multiple users. So that's one of the core issues. So I believe these peak bit rates are really not something you would see as a user generally. And as soon as you get into let's say more congested areas, then compression is relevant, and so on and so on. But I agree on that. We basically optimizing on two ends, and these two aspects are commoditizing also this. For example, what we're also seeing is that the cost of delivery for a gigabyte is being decreasing for operators, and so on and so on. So these are all the reasons why there needs to be smarter things being done than just looking at extending the bandwidth and compressing content. I think there is many more opportunities in other domains, but we might see more video more data being distributed by machine-based aspects, so by perception, and so on and so on. And that might increase the amount of data which is seeing, if you consider like robots that have many cameras, right? So I believe there are new type of devices and use cases that require both compression and high bitrate. But for the mainstream streaming, I agree that probably we don't need the extension into 6G and new compression. That's what is observed. There's a lot of harmonization, commoditization on what is existing, right? So good point.
Yeah. And then you mentioned about the internship opportunity, especially the South, branch of your company. So, if possible, let's discuss about that options and opportunities at the next April's meeting. I will attend.
Yes. Yeah, sure. So feel free to reach out so anytime, so even earlier. So send me an email or what, so we can always get back.
Okay. Thank you for your presentation, and sorry again because I am currently driving right now.
I see. All good. Thank you.
Yeah.
Safe.
Maybe
drive
at the floor. Yeah, at the floor there should be some. There would be some questions. So, yeah, 김진필 교수님, 저기 운영 부탁드리겠습니다. 네.
Thank you. Thomas, I see your short bio. There is an interesting forum. It's the Metaverse Standard Forum. Could you explain briefly?
Devi, it's hard to understand you. You're far away from a microphone, I believe.
I see your short bio. There is an interesting standard forum. The name is the Metaverse Standard Forum.
Yes.
Yeah. Could you explain briefly?
Yeah, I can. I didn't talk about. I skipped all of these XR metaverse for today. We can have another session on XR metaverse. I have a full set of things as well. The Metaverse Standards Forum is not a standards organization. It's more a forum to collect the activities from different environments. One of the core aspects is the whole ability to go into the, let's say, the spatial environment of the internet, right? So spatial means I am connecting as a body into a 3D internet. And so there is aspects of your perception of you being integrated into the real world, to formats that are required for 3D, to perception issues, and so on. So we're looking in the Metaverse Standards Forum on technologies and requirements that would require interoperability in the embodiment of the internet, right? In basically where you as a human are integrated into this into a connected world in a 3D fashion. And there's different use cases. There's the avatar communication, for example, is part of this. There is perception sensing. There's also more regulatory and ethical issues being discussed and so on. So that's what the Metaverse Standards Forum is discussing. We setting up some webinars as well. There's a lot of public information available for the Metaverse Standards Forum presentations. You can go there as well. So it's really a pre-standardization environment to understand whether are the requirements from the industry where standards would be needed.
Okay, thank you. Which company or which country attend the forum? Which company?
I mean, we predominantly we have those that operate in, let's say, the metaverse from Meta, Google, Niantic. We also have some players from the industrial metaverse that look more 3D, like Siemens, but also many smaller companies, network operators, and so on. So it's a mixture of many companies. We have a sign up of like 1,000 companies, more than 1,000 companies initially, but mostly those that have services in this domain.
Thank you. Could you introduce some chair from the Metaverse Standard Forum?
JP, it's impossible to understand.
I will ask you about the Metaverse Forum by email.
Oh, yeah. Please go ahead. Yes.
Yeah. Okay. Thank you. Today's Dr. Thomas explained the streaming and format, technology and standard body about the video delivery. Thank you. Thank you very much. Is there any question? Yes. Thank you so much.
Okay. Thank you.
Thank you, and see you later.
Bye-bye. Happy holidays.